We have more and more technology everywhere, in offices, in houses, in public places. This is great because it gives us more and more services, and on the whole that's been of great benefit to society. But it also means that data is flowing in ways that we might not fully understand and being used in ways that we might not fully agree to. I'm Mark Ryan, I'm Professor of Computer Security here at University of Birmingham. 5G gives us much greater connectivity and much reduced latency of communication. And therefore it brings both privacy and security risk to people who have IoT devices in their house. There'll be much more data flowing from your house to cloud servers, and that represents a privacy risk for citizens. Attackers, thanks to this 5G connectivity, could attack remotely and thereby gain a foothold into your home network, and from there attack other things inside your house.
I have found security flaws in a wide range of products, ranging from contactless payment cards to implantable medical devices to car key fobs, banking apps and pacemakers. In the case of the contactless cards, we analyzed the chip used in payment system for public transport, such as the Oyster system in London, and we found vulnerabilities in the design of the cryptographic primitives used in the chip, which allowed us to, for instance, top up the credit on the card.
Although cryptography protects messages in transit, there is a risk that attackers attack the endpoints. For example, an IoT device in your house could be attacked, and then the data that it's going to send encrypted could be intercepted before the data is encrypted and sent in the clear to an attacker.
All of cryptography, all of the ways we keep our data secure is based on certain mathematical truths, mathematical systems which are believed to be unbreakable. Quantum computer will change that. It will break about half of them, so half of the mathematics we rely on to keep our data secure will no longer work.
Cybersecurity is what economics call a market for lemon. Because consumers cannot assess how much security is in the products that they are buying, they tend to buy the cheaper products, which then drives the prices down. And implementing a good cybersecurity practice is expensive, and therefore that disincentivizes producers to build secure products. And then there are also technical challenges. Getting security right is really difficult. I see a lot of vulnerabilities in products where software developers are implementing cryptography that they don't fully understand.
To resist quantum attacks, we'll need entirely new mathematics, entirely new ways of encrypting and protecting data. So these will have to be developed and proved correct, but then they'll also have to be implemented and put into real systems, which will be a huge challenge on its own.
I think universities are in a good position to take a long-term perspective on cybersecurity. This is often quite difficult for companies to do because companies are always rushing to get products to market. They often don't have the staff resources or the time to take a longer-term perspective. But another role that we certainly play is looking at products and assessing their security.
Offensive cybersecurity research is important because it's the best that we can do at the moment. To have a manufacturer come up with something and then have as many people as possible looking into it, trying to break it. And then when we find vulnerabilities, we report that to the manufacturer fixes them, and by doing so, we are improving the level of security of the product.
When we've reported vulnerabilities to companies, we've had a whole range of responses. One bank in particular, we reported an attack to them on a Friday, and we had it fixed by a Wednesday. Fast, effective, a good reaction. Other companies have taken months to address serious issues in their system, which could have put all of their customers at risk. If we didn't discover these vulnerabilities and report them, there's a really good chance cybercriminals would find them first and use them to attack real systems. So for every vulnerability we report and get closed, that's one less possible attack which could take place.